This problem, we're looking for the moment around direction AB, or axis AB, caused by that single force acting on the pipe. So, mathematically, in the find step, we want in Cartesian components what this vector is. So we are looking for m bar AB bar. So the vector of the moment around axis AB is what we're trying to find. Right? And given, all that we're given here is the diagram. Right? So we'll make our own version of this diagram. I'm going to stick with the coordinate system that they started with here. So here, y is to the right, z is up, and x is coming towards us. So we have the pipe going from A to B, and then from B to C. So I'll represent the pipe in a different color. So from the origin up to here. And they give us F already in its component form. So F, they tell us, is negative 20I plus 10J and plus 15K. And that force is in newtons. And then it's 3D, so again, we want to put the coordinates of all of our points down. A is the origin. B is going to be situated at 3, 4, 0. And C is going to be situated at 3, 4, 4. So one force, again, we are interested in the moment around the axis determined from A to B. So this axis here is what we're going to be ultimately concerned with, the moment about that. So this is the diagram we need. So we can go to our equation step. Again, we can start at the end and kind of work our way forward. So ultimately, we need the moment around axis AB as a vector, which means we're going to need it first as a magnitude, and then we're going to multiply it by the direction from A to B, u hat AB. So to get MAB, what we're going to do, so the magnitude AB, we're going to take the moment around a point that lies on this axis. Easiest one is going to be the moment around point A, and we'll dot it with that direction AB. Again, we also have the option to use any other point, so for example, MB, and we'll get the same result. But like we saw in the last example, taking around A, which in this case is the origin, is usually just going to be easier to do. So, we don't know this, which means we don't know any of this yet, so we want to get our start that way. So let's start by finding what is the moment around point A. So we're going to use R cross F here. So again, what are we interested in? We need to know which R we're going to use. Well, we want the moment around point A, so that already solves that question. So where is it pointing to? It's pointing to where that force is being applied. So in that case, we need RAC. Cross F, F we already know in component form. RAC, we don't yet know in its component form. So let's solve that. So position vector, RAC, is going to be endpoint minus start point. Well, the start point is the origin, and the endpoint is 3, 4, 4. So this means it's going to be 3I plus 4J plus 4K. And this is going to be measured in meters. So going through this cross product step, second line, RAC, 3, 4, 4. And then the third line, third row, components of F. So we're given that negative 20, 10, and 15 newtons. So as before, I'll leave it to you to expand this out. But what you should get in the end is that the moment around point A is going to be 20I minus 125J plus 110K Newton meters. Like we saw in the last problem, we're going to take this and kind of put it aside for the moment. we have this quantity, which means we have this quantity. We now want to dot this with u hat AB. So find u hat AB, we normalize position vector RAB. So point B minus point A is going to give us 3I plus 4J, magnitude of 5. So 3/5 I plus 4/5 J is unit vector AB. Now we can calculate the magnitude of the moment around axis AB. So we're going to take this quantity that we found earlier, 20I minus 125J plus 110K, and dot that with u hat AB, which we just found, 3/5 I plus 4/5 J. Done with this for the moment. Carrying out the dot product with two vectors, 20 times 3/5 minus 125 times 4/5. The magnitude we get out of this is negative 88 Newton meters. This is dimensionless. This had units of Newton meters. We have this. We now have this. So we're ready for the last step, expressing this moment around the axis as a vector. So we're going to take what we just found, negative 88 Newton meters, and multiply it by u hat AB, 3/5 I plus 4/5 J. So multiplying this out, we're going to get that the moment around axis AB in Cartesian form, negative 52.8 I minus 70.4 J, and again, Newton meters.